Welcome back to Obsession Engineering and the 749 project. This will be second day in a row working on the Ducati, which is a godsend really considering I didn't touch it for 6 months. So I've actually written a list of all the things that need doing to the bike. It's not a terribly long list, but some of them will take a while. And what I'm going to do is start with the thing that's at the top of the list, which is exhaust. So what I'm going to do is I'm going to give that a little bit more of a clean up, and then I'm going to refit it, because once that's on, I can fit the rear sets and a few other bits, and it'll start looking more like a bike. So right, Scotch-Brite pad, exhaust pipe, bit of rubbing. What fun. I started off with GT85 and a Scotch-Brite pad, and I wasn't making a lot of progress. Nothing was really coming up any better. So then I decided to crack open the Dr. Downpipe and give it another go with the Scotch-Brite and just sort of get quite into it with my fingers and stuff. And when I originally got this, I tried it and I'd been sort of slightly oversold it that it would be a miracle cure and my exhaust pipes would look like brand new straight away, and they don't. This pipe is looking really quite nice now, and this one is looking considerably better, although not perfect. It's got quite a lot of sort of pitting and imperfections in it, but I'm not sure I'd get them out without blasting it and then polishing it, and I don't really want to do that. So what I'm going to do next is give them another spray with Dr. Downpipe, put them outside in the rain, give them a bit of a splash off, and then let the rain wash the rest of it off. They should look something like clean pipes. While the header pipes have a little bath outside in the rain, I'm going to move on to the thing that should be here, the radiator. Now, I have the original radiator, and it sort of lives up there, and this holds water perfectly well and probably functions okay, but the core's a bit blocked up, it looks a little unpleasant, and one of these little fins at the side that locates the sort of breather tubes and infill panels and stuff like that is falling off. And I suspect welding that back onto a slightly corroded radiator would be a bit of a disaster. So what I've done is I've upgraded to a Chinese radiator. Now, I've used Chinese radiators on my 750 classic race bikes, and they work perfectly well, and they're that good a copies, they might even be made in the same factory that made the originals. So that I need to build up. I need to put the fans on it first, and then I can fit that to the bike. I might have found a little bit of a problem. Nothing too major, but this isn't original equipment radiator, that's for sure. I mean, it is probably a fifth of the price of an original one, so I'm not going to whinge too much. But this fan fits perfectly. This fan does not. That hole and that hole line up, and that one is quite a long way off, to the extent of I can't even see the hole through that hole into that hole. So all I need to do is estimate a little bit of a position and drill a new hole in the fan. It's not the end of the world, but it's not ideal. So now I've got both fans fitted. In the end, I didn't actually re-drill it, I just filed the hole a little bit to slot it, and that now fits perfectly well. The fans both spin without actually hitting anything, so it's always worth checking that they're not hitting the matrix. So I just need to turn that over now and fit the rubber sort of boots that go on here, and this is one of them. So it slides onto there, and then it's got a cutout in here that the sort of air tubes slot into. Right, so the new radiator is going to fit just in here, so I'm just going to take the fasteners off, and I'm going to put a little bit of copper slip on each of the bolts so that in future they'll definitely come out easily. Just put a little bit of lube in the pipes as well, because as I actually fit the radiator, I'm probably going to have to slot it onto the pipes as I fit it, because otherwise you've got to try and bend the pipes that aren't actually that flexible to fit afterwards, which tends to be very awkward. So here we go. We'll slot that past here, being quite careful with it because they are nice and delicate. Right, so I'm just slotting the radiator in, and I've just put one of the bolts in loose but without the little collar on it, so I've got lots of wiggle room. That's the first pipe in, and then move it around. You don't want to be too sturdy at this point with the radiator. You don't want to put the bolts in too soon. So that's the second pipe basically in, but that will take a a little bit of tweaking, there we go. And then I have a pipe right behind here, which is ever so slightly awkwardly right next to one of the bolts, but it does fit. And then there's a little like overflow to the breather on the other side, onto the sort of cap overflow back to the radiator reservoir, the header tank. And other than connecting the fans up and putting the right bolts in, we're about there. Pretty simple. I'm sort of bitting and bobbing between different jobs, and actually what I need to do is start at the front and probably work my way back a little bit more logically. So what I'm going to do next is put the front wheel in, take that paddock stand out, and then I can put a headstock stand in that goes up under here, and that means I can take the forks out, so I can then service the forks, put them back in, put the front wheel back in, clean the brakes, do the whole front of the bike, and then work backwards. This seems like a lot more logical way of doing it. It is the first time this bike's had a front wheel back in it for quite a long time, so that's quite nice, but it is coming out again in a minute, so the spindle is literally just slid through nice and loose. It is the newly plated spindle and a newly plated spacer and new bolts a bit, so when it's finished it will at least look correct. Right, the next thing I need to do is, before I actually slide the forks out, is write down what setting these are on, as in what height the fork tubes are at, where the preload adjuster is, and then I'm just going to get a spanner on there and I'm just going to crack the fork tops off while the forks are in the bike, because it's easier because everything's solid and stable. Right, so I've loosened off the fork caps, but this one was excessively tight, so it's always useful to undo the pinch bolt first, just in case. But this one, I don't know who'd done it up, but I think Jeff Capes had a go at it, and unfortunately when I undid it, my spanner actually slipped slightly and it has marked the fork cap, and this has annoyed me. Mostly because they don't need to be that tight. They seal on an O-ring, so you don't need to smash that really, really hard into the tube. So it's a little bit annoying, but it's done now, so it's too late. Right, next thing to do is take the front wheel out, undo the rest of the pinch bolts, and then just slide the leg out. But what I'll also like to do is I like to cable tie the sort of handlebars up into the top yoke, so all the brakes and everything are basically held in the right place, so you don't end up with reservoirs upside down and mass cylinders and stuff. So that is it. Before you know it, the forks will be out. I'm up in my suspension area now, and I have the fork lightly in the vise. I've taken the rest of the preload off it, I've checked the rebound setting, and if we go all the way down to the other end of the fork, up the hole there is the compression adjuster. So Ducati are quite prone for doing this, and it does mean when you put the front wheel spindle in, you have to make sure that you have the spindle turned correctly, so the hole in the spindle is in the right place to get to your adjuster. Otherwise you're not adjusting anything. So right, that's all done. The chrome is in nice condition on these. There is no particular marking on there, but obviously the dust seals aren't very good, which means the fork seals probably aren't very good, the oil seals, and I suspect the oil itself won't be particularly nice. Now before I actually go ahead and take the fork top off, what I am going to do is just crack off the bolt in the bottom of here, because I am going to take the damper rods out. It's a little bit unnecessary, but while I'm in there I may as well go a little bit extra. You know, the extra step, make the job right. So all I did there was I just put that foot in the vise and I just cracked it off a little bit with a socket on a decent ratchet, and now I'm just going to loosen these a little bit more to get them to the point where they're just basically hand tight. So you can see there the O-ring that this seals on, and I've got those fairly loose now. So this is why you don't need to do these really, really tight. They're not sealing like that piece of metal against that piece, they're just sealing the O-ring in the tube. So as long as they're just nipped up, they're absolutely fine. There are 14 clicks of adjustment on this rebound adjuster, and I like to leave them when I take them apart wound all the way in, so that's in effect the same bottoming position. And that will vary depending on where the lock nut is and the top cap on the threaded rod of the damper rod. So it is useful for when we need to put them back together. This information is in the workshop manual, but I find it's always useful to just check yourself. Now we're in the spring compressor, so this is just screwed down and pushes the spring down. It compresses the spring, being a spring compressor. And then what I can do is I can lift this up and I can get to this lock nut here that goes onto the preload adjuster. And what I need to do next is get two spanners and unlock these. Unlock those nuts, or unlock the lock nut, and then, holding the damper rod like that, I can just spin the fork top off. Nice and easy. So fork top off, and I'll take the little spring spacer as well, and this one's got the actual whole damper rod with it, like the adjuster rod, so I'll put that on the sink. And now I can take the pressure off my spring compressor, release the spring back, and with that released I can take the fork out, take my preload spacer and my spring out, and pour this upside down into the sink, drain all the oil away. And you can see how horrible and black that old oil is, so that clearly won't have been working at its optimum level, so it is a good job we're taking these apart. So the next thing to do is to take the damper rod out of the fork leg. So impact gun just spins the bolt round a little bit quicker, which tends to make life a little bit easier, and I've got a sort of little homemade damper rod holding tool in the other end. It's just a piece of pipe with a bit of a castellation on the end. There we go, that is the bolt loose, so then I can slide the damper rod out the hole. Nice and easy. So I've just slid the dust seal down the fork leg. I'll just get the screwdriver around it and give it a little bit of a tap, and then I'm going to get in here with the smaller screwdriver and flick the circlip out of the way that actually retains the oil seal. So circlip out, and then we have to look a little bit brutal. I'm just going to hold on to this end, and we have to slide the seal and the bushes out the tube. And there we go, seal, bushes. So the reason I've decided to go one step further than just changing the oil in the seals is to actually take the damping items out of it and strip everything and clean it a bit more, is for states like this. Because the oil was filthy, you've got all this sludge sitting around the damper, around this compression damper, and obviously this is bits of old O-ring and just sort of carryover that's been dragged into the fork, and bits of old bush, and obviously if this is going through the actual shim stack, you're not going to get efficient damping. I mean, bits like that, it's never going to be working as it should do. So what I'm going to do is give that a thorough cleaning, and then we should actually get damping like the bike was new. So what are we actually looking at here? Well, this is the compression valve. So basically this is a selection of shims and a little taper valve that adjusts our compression damping. So there's a hole in this end, and there's holes down here, and these bypass past the actual shim stack. So when you adjust the adjuster, which is in the bottom of here, when you adjust that, that basically winds a taper in and out of this hole. So if you wind the adjuster all the way in, it basically blocks this hole off and stops oil going through this bypass, which means all the oil has to go through the shim stack. So you see all these holes in the shim stack. This is a non-return valve for when the oil is going the opposite way in rebound. So when we're in compression, that one will be closed. The oil will pass through underneath here in this gap, through there, through the actual piston, and then it will open up this shim stack. So this element just here is actually a shim stack. It just doesn't look like it because it's so dirty. So in fact, we'll give it a clean, and now you might be able to just make out that this is actually a series of little shims. So these are sort of 20mm diameter-ish thin metal shims, and there'll be about 8 or 10 of them. And what happens is when you push the oil through here, it'll actually just deflect these shims out of the way, and then it controls the amount of oil. So basically, if you have thicker shims or you have more of them, it'll be harder to push the shim stack open, so it'll give you harder valving. So if you've got a bike that's really, really harsh over the bumps, it tends to be that these shims are really aggressive. If you have a bike that floats over the bumps, it tends to be that there's either less shims or there'll be a selection of different sizes, so you get a different amount of valving. So when people talk about revalving, what they're doing is altering these shims or altering the whole piston assembly. So this only controls the compression damping. There is one on the damper rod that controls the rebound. So let's have a look at that. So this is the actual cartridge. This is the bit that does the damping. So we've got the compression valve will sort of basically sit at this end, and when this bit that's attached to the fork top pushes in, obviously it pushes oil along here and through the compression stack. Then when it's going the other way, oil is pulled back up this way and the piston is pulled back through the oil. So if we take this apart, and these Ducati ones are incredibly easy to take apart because there's actually no bump stop on these. There is a top out spring in there, but that's their story for another day. So right, we have basically the same thing as on the compression stack on the rebound stack. We have a non-return valve on here, so when we're in compression, like going that way, the oil will flow straight through the shim stack and open that non-return. We've got like a seal ring on there that seals against the inside of the cartridge, and then when we're in rebound, so we're going this way, the oil will flow this way through the big hole there, through this gap, through the shim, the piston, and push these shims open. Whether we can actually open them with our fingers, you might just be able to make out there, just opening there. So basically it just flexes the shims open. So you'll see on here there is a hole down this end again, and a hole here, so that's the bypass for your adjuster. So when you adjust your damping, you just adjust how much is going through the bypass, you don't actually adjust the shimming. Now obviously this, because it's going up and down, and this is the bit that's moving the oil around, this will actually affect compression and rebound, because obviously in compression it's moving that way, and so oil could just flow straight through it. So the adjuster that affects the rebound obviously affects the compression as well. The compression one purely does compression. So this is the really important end of the assembly really. If you get your rebound stack completely wrong design and have to run the bypass nearly closed all the time, it affects your compression and vice versa. So it's all a bit of a compromise. So these laid out are the elements of the rebound adjuster. So this bit and this shim here, they go together, and these are the bits for the non-return valve, so they've basically got a bit of spring to them. And then we've got the piston, so you can see there's big holes going through either way with a sort of offset, so some of them will go against the shims and some of them go against the shims the other way, depending on which way the oil's flowing. And then all these little shims, which hopefully you can see they actually bend relatively easily, these are the rebound shims. So these control how much damping you get. Basically what you get is at low speed, when the fork is moving relatively slowly, more and more of the oil will go through the bypass, so through the hole we've left open with the adjuster, and then when you hit a bump or whatever, then the bypass can't flow any more oil, so then the oil has to be forced through the piston and to flex the shims open. And obviously the harder you hit it, the more the shim will bend out the way and give you more or less damping. So this is critical to how the bike actually feels. It's all done with little shims. Now I'm not going to adjust any of this because I've not actually ridden the bike standard, so I don't know what it's like. So I'm going to just clean all of this up, put it back together. So now I've got the damping nicely cleaned up, what I'm going to do is change the bushes and the seals. So the oil seal's fairly self-explanatory, it seals the oil inside the fork leg, that's just a washer, and then these are the two bushes. So this bush is fixed to the chrome tube and slides up and down the inside of the aluminium outer, and this one does the opposite. This one is actually pushed quite firmly into the aluminium outer and slides up and down the chrome tube, and obviously over time these wear a little bit, and the wear might look absolutely minimal, but it makes quite a difference over the extension of the fork leg. So I'm going to be changing those, changing the oil seals and changing the dust seal, because while we're here we may as well do it properly. So I've given the tube a thorough cleaning out inside, I've slid a new dust seal on, I'm about to slide my oil seal on. What I like to do is a smear of oil inside the oil seal, and the plastic bag just means any little sharp edges when you're coming over the bush areas and bits, it'll just slide over without damaging your new seal. So with my new seals and bushes fitted, it is time to fit my outer again. So I've given this a thorough cleaning, and we're just going to slide that over there and slide it down there. Now it doesn't have to slide all the way yet, because what we need to do is turn it round, put this in the vise and hammer the seal back in. This may seem a little bit of a harsh way of doing it, but it is the way you fit them. I have a seal hammer and I have a seal and bits that are trying to push it into the fork leg, and it's pretty simple. Come on, more bangs and we'll have it in. So oil seal hammered home, and what I can recommend at this point is not having your finger just over the end of there when you slide the hammer in, because that could really hurt. Anyway, we'll man up a little bit and carry on. Dust seal is just pushed in, so that means that bit of the leg is complete. The next thing to do is to put my damper rod back in, which is just a case of sliding up from that end, getting it about in the right place, and putting our cleaned up compression damper in from this end, screwing it all together. So now I've got the cartridge dampers all cleaned up, all that's reassembled, bushes and seals fitted. It is time to put some oil in it, so I've moved back to the low vise. I have my pull-up rod, because that makes life a little bit easier, and we're going to be using Motul 7.5 weight fork oil. The majority of forks nowadays use 5 weight, but Ducati always seem to spec 7.5. Their choice, who am I to argue? So, the first thing we need to do is pour plenty of it into our fork leg. I've poured plenty of oil in there, so it is in fact nearly full. I'm just going to move this up and down a couple of times to make sure we've got all the air and bits out between the two outers, the two legs, and then I need to pump my shaft because I need to move this up and down to force the air out of the cartridge and replace it with the oil so that we actually have some damping. So a little bit more oil. Just put the lid on the floor for a minute. So a bit more oil, and I can feel there some nice consistent damping through the stroke, so that tells me we've got rid of all the air. But what I am going to do is leave that compressed, give it a couple of minutes for all the air bubbles to come out before I set the air gap. So it's had a couple of minutes for the air bubbles to come out of the oil, and now we're going to set the air gap. And to do that, I have basically a fancy big syringe, and that is 104 millimeters from where the oil will be to the top of the fork. So you do this with the damper compressed and the springs and spacers all removed. So we just put that in there and give it a suck. Slurpy slurpy. Do it a second time, just be sure. So now my air gap is set, now I can refit the spring and the spacer, once I've given them a little bit of a clean. Spring in. Preload tube in. It's a very long preload tube. And that's why we have the pull-up tool, because that nearly didn't fit. So what I need to do next is put this back in the spring compressor, push everything down a bit. So we're moving into the final stages now. The spring is compressed, pull up the pull-up tool, and I'm just going to wedge a tool in there to stop the damper rod disappearing back inside the fork leg, because that at this stage would be awkward. So now I have my fork cap with the rebound adjuster tube on it. We're just going to slide that down there and screw it down here. And now this is why I had the rebound adjuster wound all the way in, because you can set the distance for the fork cap onto the tube. There is probably a measurement for the actual amount of thread near the nut and all this stuff, but I tend to find it much easier, assuming it was set right to begin with, to wind it down. And I can feel that now is just bottoming. So it's just bottoming the rebound adjuster into the shim stack, basically. And you can see there, we've got a little bit of spare on the nut. So what I'm now going to do is wind the nut up to the top cap, lock the two together. And I assume it had the right amount of adjustment. 14 clicks is about normal for a road bike set of forks. Right, so I'm making sure here that I actually turn the lock nut on the damper rod more than I'm turning the fork top. So they're nicely nipped together. And then what I'm just going to do is get a screwdriver on and make sure we've still got 14 clicks of adjustment. Because if we've got less, then what we can do is undo the lock nut and screw the fork top up a little bit. And if we've got 20 clicks of adjustment, we can screw it down a little bit. Do we get the right number? The first click out is 0 from fully in. So 0, 1, 2, 3, 4, 14. There we go. Perfect. 14 clicks. Almost like I've done this before. So now all I need to do is undo the tension on the spring compressor, take that off, and literally screw the fork top into the tube. Right, there we go. Just slide those together. Make sure the thread engages nicely, and literally screw the two halves together. And we don't have to be particularly tight when we do the fork cap up, because as we already know, seals on an O-ring, it doesn't have to be tight. So just going to do a little demonstration of how much difference the adjusters actually make. So at the moment I've got the rebound and the compression adjusters wound absolutely solid. And the fork is quite hard to push down and comes back quite slowly. So that is pretty firm. Now the first thing I'm going to do is open up the compression adjuster. So that's now at 6 clicks out, which is how I found them. And you can see it's still fairly firm. It's not made that much difference. But this will be the interesting one. This, when I found the forks, was at 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now have a look at this. There's still some nice control to it. It goes up and down, it's controlled, it's not just disappearing through the stroke and bouncing back up really, really fast. But it would be a considerably nicer bike to ride with this in it than it would with the adjusters wound solid. So that's one leg done and one leg to do. Thanks for watching, and join me again soon when I'll be putting the forks back in the 749.